Good morning, everyone. So, we have to start with chapter 3 now, that is playing with numbers. Before starting the chapter, you have to revise tables from 1 to 20 or at least from 1 to 15. Also, you have to revise the divisibility rules that you have already studied in class 4th and 5. We will also attach a slide of divisibility rules at the end so that you can have the content to revise it. So let's start playing with numbers, with factors and multiples. What are factors? A factor of a number is an exact divisor of that number. Exact divisor means when we divide it by a number, we get remainder 0. Let's quickly see some examples. For example, 1. 1 comes in table of 1 only. So 1 is divisible by 1. So factor of 1 is 1. Every number comes in the table of 1. So another example, let's take 2. 2 comes in table of 1. That is 1 2s are 2. It comes in table of 2 also. 2 1s are 2. So factors of 2 are 1 and 2. So 1 and 2 are the exact divisors of 2. When you divide 2 by 1 or 2, you get remainder 0. For example, 3. 3 comes in table of 1 and 3. 1 3s are 3 and 3 1s are 3. None other number, right? So factors of 3 are 1 and 3. So 1 and 3 exactly divides 3. Let's see which all numbers exactly divides 4. 1 4s are 4. So 1 exactly divides 4. 2 2s are 4. So 2 exactly divides 4. 3 does not divide 4. 4 1s are 4. So 4 exactly divides itself. So factors of 4 are 1, 2 and 4. Let's learn another way of finding the factors of a number. So try different arrangements. Try to arrange 8 pots in such a way that it forms a rectangular boundary. So number of rows multiplied by number of columns will give you number of pots. So here we have 8 rows and 1 column. So number of rows 8 multiplied by number of columns 1. 8 1s are 8. So there are 8 pots and we can arrange it in 1 column and 8 rows. So this is the first arrangement that you can do. Somebody else can arrange it in 1 row and 8 columns like this arrangement. There is 1 row and 8 columns. So number of pots, number of rows multiplied by number of columns, 1 8s are 8. So this is also can be arranged to get a rectangular boundary. So we have seen 2 arrangements. Let's see few more. Another arrangement could be 2 rows and 4 columns to make it 8. 2 4s are 8. So this can be one more arrangement. Let's see one more. Next is 4 rows and 2 columns will also give you 8 pots. 4 2s are 8. So these all are the possible arrangements. You can try any arrangement yourself also to get 8 pots, but keep in mind that you should get a rectangular boundary. So what does these arrangements show? 1 8s are 8, 8 1s are 8, 2 4s are 8, 4 2s are 8. Now if you see carefully, 1 exactly divides 8, 2 exactly divides 8, 4 exactly divides 8 and 8 itself exactly divides 8. So these arrangements show the factors of 8, right? So factors of 8 are 1, 2, 4 and 8. There is none other number which exactly divides 8. So these all are the possible factors. So through these arrangements, like these arrangements, we can try and arrange and we can find the factors of numbers. Now this is very easy when we get small numbers like 4, 6, 8, but when it comes to bigger numbers, it is not possible for us to try different arrangements because there will be many possible arrangements. So for that you have to be very thorough with the divisibility rules. You should look at the number and you should be able to check whether it is divisible by 1, 2, 3, 4, 5, 6 and so on. So divisibility rules will help you to understand which all numbers exactly divides a given number, and you can find the numbers factors easily. Now as a practice, try arranging 18 marbles in rows and find factors of 18. It will be fun for you. Now let's learn how factors play with multiples and how multiples play with factors. Very simple example in front of you. 9 8s are 72. So 9 exactly divides 72. 8 also exactly divides 72. So as you all know, 9 and 8 are factors of 72, right? So 9 and 8 are related to 72. How 72 is related to 9 and 8? 72 is the multiple of 9 and 8, right? So we get a relationship. If 9 and 8 are factors of 72, then 72 is multiple of 9 and 8, right? Now let us see how many numbers have 72 as their multiple. Starting with the table of 1. 1 into 72 gives you 72. 2 into 36 gives you 72. 3 into 24 gives you 72. 4 into 18 gives you 72. 6 into 12 gives you 72. 8 into 9 gives you 72. Now, how to understand whether there may be more numbers which have multiples as 72 or not is very easy. Let's follow the divisibility rules starting from 1. Since 1 is a factor of every number comes in table of 1. Next, 72, the ones place is 2. It is ones place is even, so it is divisible by 2. So 2 into 36, right? Now if you see the multiplier and the multiplicand, multiplier keeps on increasing and multiplicand keeps on decreasing. If you see the third example, the multiplier is 3 and the multiplicand is 24. How is it divisible by 3? Because sum of the digits of 72, that is 7 plus 2 is 9. So it is divisible by 3. So 3 into 24 is equals to 72. Now you see the multiplier was 2 earlier, now it became 3. And the multiplicand was 36, now it became 24. So multiplicand is decreasing. So you don't have to check the numbers, check the tables from 25 and 35, right? Now the next number after 3 is 4. What is the divisibility rule of 4? That the last two numbers, last two digits should be divisible by 4. So it gives you remainder 0. So 4 into 18 is equals to 72. Now after 18 you don't have to check any table till 24. So these numbers got less. Next table is 5. The divisibility rule of 5 is that the ones place should be 0 or 5. So 72 is not divisible by 5. So 5 is not a factor. Next is 6. If it is divisible by 2 and 3, then it is divisible by 6 also. So 6 into 12 is equal to 72. So now you got the multiplicand as 12. If you go in a sequence, it will be easier for you. Now between 12 and 18, there are numbers 13, 14, 15, 16 and 17. So now you don't have to check these numbers, right? Now next after 6, we have a number 7. So 7 10 70 होता है. It does not divide 72. Next is 8. 8 9s are 72. That is very easy. So 8 9s are 72. You got multiplier as 8 and multiplicand as 9. So there comes no number between 8 and 9. So when you reach such a stage, when you get two consecutive numbers, it gives end to the multiples, to the factors, and between 9 and 12 there are numbers 10 and 11. You don't need to check those numbers, as though they will not give you any multiple as 72. So this is how the number gets decreased and we get a limited number of factors. So 72 is a multiple of 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36 and 72. Also, all these numbers 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36 and 72 are factors of 72. Now let's observe few properties of factors and multiples. So one side you are looking, we have written the factors of different numbers, and other side we have written the multiples of different numbers. Now let's start with the first example. Factors of 2 are 1 and 2, and multiples of 5, 5, 10, 15, 20, 25, 30, right? So move on to the next example. Factors of 10, 1, 2, 5 and 10. Factors of 50, 1, 2, 5, 10, 25, 50. Factors of 72 we just studied, 1, 2, 3, 4, 6, 9, 8, 12, 18, 24, 36 and 72. Now if you see, the common in all these, the factors of all these numbers is 1. 1 is a factor of all the numbers, right? Also if you observe factors of 2, the last factor is 2. If you observe the factors of 10, the last factor is 10. Observe the factors of 50, the last factor is 50. Observe the factors of 72, the last factor is 72. Means the highest factor of a number is the number itself, right? Also you can observe that there are limited number of factors, like 2 have 2 factors, 10 have 4 factors and so on. So there are limited number of factors. Also, factors of a number are either smaller than the number or equal to the number. All the factors of 2 means 1 and 2. 1 is smaller than 2 and 2 is equal to 2. Factors of 10, if you see, 1, 2 and 5 are smaller than 10 and 10 is equal to 10. If you see factors of 50, 1, 2, 5, 10 and 25 are smaller than 50 and 50 is equal to 50. So all the factors of a number are either smaller than the number or equal to the number, right? Now observe the properties in multiples. Multiple of 5 is equals to 5, 10, 15. Now just see the first multiple. Multiples of 5 is 5. First multiple of 5 is 5. First multiple of 9 is 9. First multiple of 15 is 15. And first multiple of 100 is 100. So the smallest multiple of a number is the number itself. Just see the other factors, other multiples, they are increasing. So all the other multiples of a number are greater than the number. See the multiples of 5, 5, 10, 15, 20, 25, 30. 10 is greater than 5, 15 is greater than 5, 20 is greater than 5, 25 is also greater than 5, and so on. The multiples goes on till infinity. They are infinite. So multiples of a number are infinite. Also multiples of a number are either equal to the number or greater than the number, right? So these all are the properties that you can observe here. So let's briefly write down the properties of factors and multiples. Properties of factors. 1 is a factor of every number. Every number is a factor of itself. every factor of a number is less than or equal to that number. Number of factors of a number are finite. Properties of multiples. Every number is a multiple of itself. Every multiple of a number is more than or equal to the number. And number of multiples of a number are infinite. So these are the differences in the properties of factors. And you can observe these properties in every example that you will do. Now let's play with numbers. Let's add factors, all the factors of a number, and see what happens. For example, factors of 28. So 1, 2, 4, 7, 14 and 28 are the factors of 28. Now find out the sum. 1 plus 2 plus 4 plus 7 plus 14 plus 28 gives you 56. Now if you observe, 56 is equals to 2 into 18. 56 is divisible by 2. So 2 into 28 gives you 56. Or you can say 56 is twice of 28. Right? Now another example, let's take 6. Factors of 6. 1, 2, 3 and 6 are the factors of 6. Now try to find out the sum. Sum of factors is 12. 1 plus 2 plus 3 plus 6 gives you 12. Now 12 is again divisible by 2. So 12 can be written as 2 into 6, or we can say that 12 is twice of 6. Now it does not happen with the factors of every number. Here we have taken two examples, 28 and 6. So here we come up with the conclusion that 56 is twice of 28 and 12 is twice of 6. So what we can say from this observation is 56 and 12 are perfect numbers. So we can generate a definition of perfect numbers from here. A number for which sum of all its factors is equal to the twice of the number. Such numbers are called as perfect numbers. So you can try adding the factors of other numbers yourself and try to find out the perfect, much more perfect numbers. So let's move on to the exercise questions now. This is your notebook work that you have to do in your notebook. Exercise 3.1, question number 1, 5 parts A, B, D, G and L. Question number 2, A, B, C. Question number 3 and question number 4. Now let's practice few questions out of these questions and try doing exercise 3.1, these parts in your fair notebook carefully, and we'll be discussing the doubts of exercise 3.1 in the next virtual session. Question number 1 is, write all the factors of the following numbers. A part 24. So revise the divisibility rules. 1 is a factor of every number, so 1 into 24 is 24. Next number is 2. 24 is an even number, so it is divisible by 2. 2 into 12 is equal to 24. If we check the divisibility rule of 3, 2 plus 4, the sum of digits, 2 plus 4 is equals to 6, so it is divisible by 3 also. 3 into 8 is equals to 24. Next number is 4. The last two digits of the number 24 are divisible by 4, so it is 4 into 6 is equals to 24. So you have now reached a stage 4 into 6. So here we are left with only one number in between, that is 5. 5 does not divide 24. So here ends the factors of 24. Factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. So this is how you can represent the factors of a number. Let's move on to the next question now. Question number 2. Write first 5 multiples of the given numbers. So part A is 5. First 5 multiples means you have to start from 5 ones are 5 and you have to reach till 5 fives are 25. This is the meaning of first 5 multiples. Right, so it is very easy. Just write down the table of 5 and you will be getting the first 5 multiples of 5. So this is how you can try out the other questions yourself, and we will discuss the doubts in the next virtual session. Come up with more doubts in the next session. Thank you.